Here is the next example. In this example, um, uh, U of t is the input and resistors, capacitors and inductors are connected in series parallel combination. He clearly mentioned initial conditions are 0 and he wants us to find the voltage drop across the 1 Henry inductor. So step 1, we need to convert this into time domain. So use the Laplace transform table. So by using Laplace transform table, U of t is nothing but 1 over S. Okay, resistance value does not change and capacitance value is nothing but 1 over Cs. So 1 over Cs is nothing but 3 over S. Here resistance value does not change and inductance value is S. Now what we're going to do here, we're going to convert, our goal is finding V naught of S. So our goal, we can use the voltage division rule. To do that, I'm going to find the Zx. Zx is nothing but this 5 plus S parallel with 3 over S. So after calculations, go through these calculations. I mean, sometimes may get confused with my 5 and S. Don't get confused. So I end up with Z of X equal to 3S plus 15 over S square plus 5S plus 3. Now by using the voltage division rule, I found the Vx. So to find Vx, I have 1 ohm and then Zx. This is connected to 1 over S. So by using voltage division rule, Vx must be total voltage times same impedance divided by total impedance. So 1 over S times Zx over 1 plus Gx. So 1 over S, Zx is nothing but 3S plus 15 over S square plus 5S plus 3 plus 1 plus 3S plus 15 over S square plus 5S plus 3. Okay, once I simplify that, I end up with Vx equal to 1 over S times 3S plus 15 divided by S square plus 8S plus 18. Now we're going to find V naught. I'm going to again use the voltage division rule. So to find V naught, I have 5 ohm, okay, and an inductor S, and here is a Vx. Okay, so to find V naught equal to Vx times S over 5 plus S. So Vx is nothing but, I'm going to substitute this 1 over S. If I pull out the 3, it's going to be S plus 5 over S square plus 8S plus 18 times S over S plus 5. Now S plus 5 and S plus 5 get cancelled and SS get cancelled. I end up with V naught equal to 3 over S square plus 8S plus 18. Now you need to modify this equation to convert into time domain. So look into the, so that's, you need to practice this a lot in the inverse Laplace transformation. So if you look into the table, Laplace transform table number, I believe 19. So e to the power of at sine bt is nothing but b over, let me write it down. Okay, so e to the power of at sine bt, Laplace transformation of that is b over s minus a square plus b square. So I'm going to write this in that format. Why did I pick this? Because the given function, the s domain function, is close to this. Okay, so I can write this as s plus 4 whole square. So s square plus 8s plus 16. Still I have 2 left. So the 2, I'm going to write it down as square root of 2 whole square. So I have s minus a square plus b square. Now I have to have b in the numerator. So to get that b is nothing but square root 2 divided by square root 2. So I'm going to multiply and divide it by square root 2. So I have a constant 3 over square root 2 pulled out. Now I have square root 2 over s plus 4 whole square plus square root 2 square. So 3 by 2 is constant. So e to the power of a is nothing but minus 4 minus 40 sine b is nothing but square root of t, and u of t is a unit step function. So this is the time domain equation. Here is the next example. In this example, the given source is a current source 10 u of t. Our goal is finding the voltage drop across the 4 ohms. Okay, so first convert the given circuit into time domain. So when I convert the given circuit into time domain, this is going to be 10 over S. Okay, all I did, I switched these two because I always wanted to keep the sources on one end and the remaining elements on the other end. So u of t is nothing but 1 over s, 10 over s, and this is 1 over cs, so 4 over s. 1 Henry is nothing but s, and v naught, that 4 ohm, is going to be 4 ohm. He clearly mentioned assume initial conditions are 0. So what I did here, I used the current division rule. So if I use the current division rule, I want to find ix. Ix is nothing but total current multiplied by opposite resistance. So 4 over s over 4 over s plus 4 plus s. I mean, I'm going to repeat the current division rule. So if you have R1 and R2, I1 and I2, as long as I know I total, I1, I2, as long as I know I total R1 or R2, I can find I1. I1 equal to I total times opposite resistance over total resistance. That's the formula for the current division rule. So I applied the same formula here. So 10 over S, that's the total current, multiplied by opposite is 4 over S divided by, impedance. I used impedance here, 4 over S divided by 4 over S plus 4 plus S. This is nothing but 4 plus S. These two are in series. Okay. After simplifying it, I end up with Ix equal to 10 over S times 4 over S square plus 4S plus 4. Now V naught of S is nothing but 4 times Ix. So I used that. So V naught of S, I end up with 160 over S times S square plus 4S plus 4. Now we found the V naught of S in S domain. We need to convert that into time domain. So by using partial fraction, here I have repeated poles, S square plus 4S plus 4. So it's going to be A over S plus B over S plus 2 plus C over S plus 2 whole square. Now A I can find out by using substitution method. So take the whole equation other than the denominator of other than the denominator of A, and substitute S equal to 0. So I end up with finding A value 4. Okay. Now, but the remaining two terms, I found them by using LCM method. Okay, so here on the left hand side, I have 160 over S plus 2 whole square. That is nothing but V naught of S basically in S domain, equal to, on the right hand side, I have this. Okay, A times S plus 2 whole square plus B times S plus 2 plus C times S over S times S plus 2 whole square. So the denominators are same, numerators must be equal. So if I apply that principle, so 160 equal to A times, I expanded it, S square plus 4S plus 4 plus B times S square plus 2S plus CS. So here I don't have any S terms, so I can write it as 0S square plus 0S. Now I'm going to equate S square terms. So here I have 0 coefficient for S square. So 0 equal to A S square plus B S square. So I already know A value, I found the B value. Now if I equate coordinates of S, so 0 on this side, so 0 equal to 4A plus 2B plus C. So I found C value equal to minus 80. Now V naught of S equal to 40 over S minus 40 over S plus 2 minus 80 over S plus 2 whole square. Okay, by using the inverse Laplace transform table. So 40 over S is nothing but 40, U of S is nothing but U of T. Sorry, 1 of S is nothing but U of T. I put it at the end. Minus 40 times e to the power of minus 2t minus 80 times t times e to the power of minus 2t. Okay, thank you.